far that we've looked at, arrays are obviously quite linear, and linked lists, even though they may be circular, even though they may be doubly linked list, they still are linear in nature, right? It's one node after another. But trees are a different thing, right? It's a data structure that is not linear. So how do they work? What is the terminology that goes along with them? All of that fun stuff. So first thing is, it is, of course, a nonlinear data structure. And the way that trees are conceptualized is they start at the top. Instead of a front reference like we see with the linked list, even though these still are references, here we typically call it root instead of front. And root points to one particular node, and that node is going to be considered the root of the tree, right? Now, this is a tree where the tree is kind of backwards, or you can think of the tree actually representing the root system of the tree, not the tree itself, right? Because we think of it going down. So the root points to this first node here, and then that node can have children, right? Can have nodes below it. So that's one piece of terminology, is the root. Inside, you're going to have nodes. So there are different kinds of nodes. You have leaf nodes, and the leaf node is just a particular node that doesn't have any children. So this is a leaf node, this is a leaf node, this is a leaf node. Anything that doesn't have children, those are called leaf nodes, right? Again, they're talking about terminology as if the tree's growing up, but yet we can conceptualize it going down, which is kind of backwards, but whatever. They're called leaf nodes. If it's not a leaf node, you can say it's an internal node, although you don't hear that term too often, right? It's leaf nodes and everything else, nodes that have children, okay? Another piece of terminology here is to talk about the tree's height. And the height, or order, is the maximum distance that you can go from the root to the farthest leaf node. How far is it from the root to the farthest away child, right, the leaf node? And the way that you count this is you don't count the levels, or you can either, if you count the levels, don't count the root in the levels, or what they say is count the edges. Count the edges. So in this case, if we want to, we can see that these are all the same, right? This one and this one have the same height. This one's different, so I can pick any one of these. So the height of this is 1, 2, 3, right? The height of this tree overall is 3. We can also talk about the height starting at any one position. So if we start at C and say, what's the height? Starting at C, C would have a height of 2, right? So this tree has a height of 3. And again, you can do the same thing here, right? 1, 2, 3. Okay. Make sense? That's the height.
So C would have a height of 2 because it's from the leaf node, not from the root that you're counting.
That's right. If you're starting at C, you'd count the edges between C and its farthest leaf child.
Got it. Thank you.
Yep. You can also talk about degree, and that's how many children are off of a certain node. So this node, the root node, has a degree of 3 because it's got children 1, 2, 3 children. So the degree of any particular node is how many children it has, right? And those children might be leaf nodes, or they might have their own children. That doesn't matter with this idea of degree. It's just how many children, not grandchildren, great-grandchildren, whatever, right? Just the number of subtrees, the number of children. So A has a degree of 3, B has a degree of 1, E has a degree of 2, G has a degree of 0, right, etc. Any questions about that terminology so far? All right, so what's next? All right, so now let's get into a specialization, right? Because this first thing is just general stuff about trees, period. But this one now, we start talking about a more